So now we'll just repeat that process for bond B and C. So this is bond B now. We'll have period, our year, our cash flow, discount factor, present value, year times present value, and year squared times present value. So this bond is a 10-year bond. So we'll start out with 0.5, 1, 1 and 2. And we'll do that all the way to 20 this time. Our cash flow, same thing as before. We're going to be going to our given table, and it's just going to be equal to our coupon. We need to lock that, divided by 2 because it's semi-annual payments. So we can drag that down. And remember, we need to add back 800 in the last payment for our principal repayment. Our discount factor is going to be equal to 1 divided by 1 plus our given yield, lock that, divided by 2, raised to the period, can drag that down now. Our present value will be equal to our discount factor times our cash flow. Our year times PV will just be our PV times our year. And again, now we're just going to raise our year to the second power. Control-Shift, fill the rest there. And then we'll calculate the sums. Equals the sum. Drag that to the right, Control R. So now we can calculate our durations. And so our Macaulay duration is just going to be our year times PV divided by our present value. Our modified duration will equal our Macaulay duration divided by 1 plus our given yield rate divided by 2, and our convexity will equal our u squared divided by our present value times 0.5. Now we can add borders to this again. This will be Alt HPA. Alt HPA. And this is bond B. So you're just going to want to repeat that process for bond C, and then you're going to want to discuss why your convexity and duration are different from the duration that we were given in our instruction sheet. So for question number 3, you're going to want to watch this video and then explain how you would form a ladder, barbell, and bullet portfolio using the above bonds. The key thing to know for this is that for a ladder portfolio, you're going to have equal weights in every maturity type. So in a short maturity, short being 5 years, a middle maturity being 10 years, and long maturity being 30 years. For a barbell portfolio, we're going to have our weight split between the short portfolio and the long portfolio, or the long bond and short bond, I should say. So in this case, bond A and C. And in the bullet portfolio, we're going to put all our weight in the middle maturity, so bond B. So what we're going to do here is we're going to create a table. For our rows, we'll have weight in A, we'll have weight B, and then weight C. We will have then ladder, barbell, and bullet. So our ladder will be 1/3 for each of these bonds. Our barbell will be 1/2 for bond A. it'll be 0 in bond B, and 1/2 again for bond C. Our bullet will be 0 in A, 1 in B, and 0 in C. And then to double check that this is all correct, they should each have a sum equal to 1. So we're going to do equal sum, and they do in fact equal 1. So that is question number 3. For question number 4, now that we have our weights, we're going to calculate duration and convexity for each of these. So for each of them, it's going to be our weight in that bond, so weight in A times duration for A, and we're going to want to lock our durations when we go back up here, plus our weight in B times our duration for B, and we'll lock that, plus our weight in C times our duration in C. So we can now drag that across and it'll fill out each of our portfolios, and we see that they are all working correctly. So convexity is going to be the same thing as duration, but now we're going to multiply our weight times our convexity, and we'll lock that. So again, we're locking our convexity this time, plus our weight in B times our convexity for B, plus our weight in C times our convexity in C. Lock that as well. And then we can drag that across. So that's how you do questions number 3 and 4. Now that we're done with that, we can just add some borders, so Alt HBA, and we'll do the same thing over here, Alt HBA. For question number 5, we're going to use a linear approximation method to estimate the return for each portfolio for a parallel rise and fall in the yield curve by 150 basis points. So what we're going to do here, over in the corner up here, we'll do just BPS rise, and that's going to be 0.015 for 1.5% is equal to 150 basis points. And then BPS fall is just going to be negative 0.015. So now what we'll do, we'll go down here for BPS rise. It will be equal to negative duration times our basis points change, so F4 on basis points change. And we can now drag that across. So we see that for a rise in 1.5% under the latter portfolio, the return decreases by 14.58%. For barbell, it's negative 15.84%, and for bullet, it's negative 12%. So now for a BPS fall, it's going to be the same process. It'll be equal to negative duration times our basis points change. We need to lock that, and it should be just the inverse, but now it's positive. So now we'll add borders here, and this is question number 5.